Welcome back, Algebra 1. Today we're going to do Chapter 6.3. So we're going to continue with exponential functions. So remember, that's a function, okay, or graph, okay, the equation of a graph, where x is in the exponent. So in our last lesson, we learned the exponential function f of x equals a times b to the x power. But now we're going to change it up just a little bit, and we're going to make it something called exponential growth. Okay, so exponential growth, all we're going to do is we're going to change this b to a number greater than 1. So it's going to be 1 plus some decimal, some growth rate as a decimal. Okay. So we're going to get a times 1 point some decimal, raised to the x power, and I guess I can make those y's or something, okay? I'm just trying to say that it's going to be 1 point something. It's going to be, or 2 point something, or 3 point something, right? Whatever. It's going to be greater than the number 1. Okay, so b is bigger than the number 1. Okay, so let's go on ahead and let's try a problem of exponential growth. Okay, and we can do exponential decay as well, which we're going to work on in just a few minutes. Okay, so the population of Hillville is 5,000, okay? I'm going to circle that number because I think it's going to be important, and grows at a rate of 15%. What is the growth function? In other words, what's my exponential function for the growth of this population? Okay, well, remember that A is my initial amount, and my initial population of Hillville in this problem is 5,000. My R, or my growth rate, okay, what I have to add to 1, is 15%, but as a decimal, okay, I have to divide by 100. The easier way to do that is just to move that decimal to the left 2 places. Okay, so I'm going to get 0.15. So now I'm going to have, let's see, I'll change color so you can see it. I'm going to have f of x equals a, which is 5,000, times 1 plus 0.15 to the x power. Okay, so my b value, let's go on ahead and simplify it, is 5,000 times 1.15 to the x power. Okay, so notice my b value is greater than 1. Anytime my b in here is greater than 1, it's going to be a function that's growing, getting bigger. Okay, so there's my function. So now, and this is used in real life all the time, especially with like retirement funds. Okay, and that's why I love exponential functions so much, because it's really used in real life a whole lot. So if we know the population is growing by 15%, okay, well, what's the population going to be in 5 years? So this is something that even the Mat-Su Valley does when we're talking about roads. Okay? They're saying, well, the population's growing by 15%. We need to build some more roads, or we need a new high school, or whatever. Okay? But it helps us plan for the future. Okay, so now let's go on ahead and we're going to plug that in. So 5 years is our x value. So we're going to have 5,000 times 1.15 to the 5th power. Okay. So now I'm just going to do that math here. Okay, so I'm going to type in 1.15, and remember that's to the 5th power. Okay, so that's 2.011, and I'm going to go on ahead and round, because you guys usually aren't using these fancy calculators right now. So we're going to have 5,000 times 2.011, and if I do 5,000, 1, 2, 3, times 2.011, I get 10,055 people. So my population in 5 years is going to double. So if I only have 1 stop sign in Hillville, okay, I might have, some big traffic jams, okay, if I don't plan ahead. Okay, So I mentioned that exponential functions are used in a lot of ways. They're used in dollars, banking, loans, all the time. Because you talk about compounding and simple interest. Okay, so let's go on ahead and let's take a look at what simple interest and what compound interest is. Okay, so interest is calculated in two ways, simple and compound interest. Okay, so compound interest is interest that is paid on both the principal amount, so what you originally put in, and any interest that has already been paid. Okay, so as you get more money in your account, that more money is going to then be put into the formula as your initial amount. So your initial amount would be what you originally put in plus the money you've made. Okay, so that's in compound interest. In simple interest, it's just on your original amount. Okay, it's never on the money you've made as well. Okay, so it's always better if you're trying to make money, you want it to be compound interest. Okay. Unfortunately, when you're paying a car loan or a house loan, it's also compound interest. So you pay on the interest that's accruing or adding up in your account. That's why when you get a loan for a $20,000 car, you wind up paying $25,000, $30,000, $35,000, $40,000 by the time you finish paying it off. So I really recommend all of you take a finance class if you haven't, because you'll learn all about this stuff and ways that you can help lower your payments and such. Okay, but let's go ahead and let's look at the compound interest formula. Really, it's the same formula we've been doing. Okay, so this is A, it's your amount paid. So this is your f of x. Yeah, that's our y value. And then we have our P, that's our principal amount, or our A. We have all of this stuff here, which is our B. And we have this here, which is our X. So it's the same formula, we're just adding a few more little details in. Okay, so our 1 is still our 1. Okay, our R is the rate of interest, so what our percentage is. Our N is the number of times per year that interest is compounded. For a loan, like a home loan, it's compounded usually monthly or even daily. So you really have to pay attention to that. And that N is the number of times it's compounded at both places here. And then our T is our time in years. Okay, so let's go on ahead and let's take a look at this. It says Kim's family invested $3,000 in a CD for her, so a certificate of deposit. That's something a lot of people do because you can get one for 6 months, you can get one for 10 years. And it's very safe. It just tells you right off the bat how much interest you're going to make. Okay? So it says the annual interest is 8%. If the interest is compounded quarterly, what is the value of the CD at the end of 15 years? Okay, so if it's compounded quarterly, how many times a year do we see that interest? We're going to see it 4 times a year, so that's our N value. Okay. Our T value is the number of years. Our initial amount is $3,000. And our R is that 8%, but remember we have to change it to a decimal, so it's 0.08. So now I can just plug this in. So I have my A, my final amount. So this is the amount that Kim is going to have when she's 15 years old, okay, from this CD. So A equals my principal amount, which was $3,000, times 1 plus, now it's my rate, which is 0.08, divided by 4, okay, the number of times, to the 4 times 15. Okay, so we can do this in pieces, okay, since most of you probably, once again, don't have these fancy calculators. So I'm going to start inside the parentheses. So I'm going to do 0.08 divided by 4, and that's 0.02. So now I'm going to do 1 plus 0.02, and that gives me 1.02. So I have 3,000 times 1.02 raised to the 4 times 15, and that's going to be 60. Okay. So 1.02, remember I have to follow order of operations, so I have to do my exponent first. So to the 60th power, and then times that 3,000. Okay, so she's going to have, at the end of 15 years, $9,843.09. Okay, not bad. Okay, her parents put $3,000 in a CD. They let it sit for 15 years, and now she's got almost $10,000. Okay, but let's take a look at this. So now it says, well, they did all this, okay, the same stuff, so they put in $3,000. They waited for 15 years. The interest rate was that 8% or that 0.08. But now it's only going to compound annually. So our N value is 1. So now let's see what happens, how much money she gets if it only compounds annually. In other words, you're only paying on the interest you've earned one time a year. Okay? So we get A equals 3,000. Okay, so we're just plugging stuff in. Times 1 plus 0.08 divided by 1 raised to the 1 times 15. Okay, so now let's simplify that. So we get 3,000 times 1.08 to the 15th power. Okay. So 1.08, not divided by, to the 15th power is 3.17 times 3,000 equals $9,516.51, just about 51 cents. Okay. So which one of these is better? Well, the first one. So compounding quarterly is better. And the reason is because it's going to pay on interest 4 times a year. Because it pays on the interest plus the initial amount 4 times a year instead of only 1 time a year. If this was monthly, it would pay on that interest 12 times a year and be even more money. Okay, so the more times it's compounded, the more money it's going to be, and that means the more money you're going to owe, or the more money that's going to get paid to you, depending on whether it's a loan or that you're paying off, or whether you've got some money invested somewhere. So this is when we're actually earning money, okay, or things are getting bigger. That's exponential growth. Now let's talk about exponential decay. It's the exact same thing we just did, except instead of it being a plus an R, it's going to be minus an R. In other words, our B value is going to be less than 1. So let's go on ahead and take a look. Okay, so a posted video gets 8,192 views. Okay, so I'm going to post my video right here on 6.3 notes, and I'm going to get 8,192 views on the first day. Okay, so that's my A value, my initial value. But the number of views decreases by 25% each day. So as a decimal, divide by 100, or move that decimal place over to the left 2 times. That's going to be 0.25 as my rate. And it says, hey, how many people are going to watch this now on the 8th day? Okay, my video is not as cool on the 8th day, so I'm probably not going to have as many views. Okay, so let's go ahead and plug this in. So I get f of x equals my initial amount times 1 minus, because my views are decreasing, okay, minus 0.25 to the x, which is 8. Okay. So 1 minus 0.25 is 0.75, so 0.75 to the 8th power is 0.10011. Okay, so f of x equals 8,192 times 0.75 to the 8th power, which is 8,192 times 0.1001. Okay. So now I'm going to do 8,192 times that 0.1001, and I get 820. So on that 8th day, okay, I'm only getting 820 people watching my video on 6.3 exponential growth and exponential decay. Okay, my video just isn't as popular anymore. Okay, so it's same exact formula. Okay, 1 minus r to the x here. Okay, and here it was just 1 plus r to the x. So there's really not as many formulas here to memorize, okay, as you think there are. They're really all the same. Remember, this one's the same as well. It just looks a little different because it's got a little extra stuff in it. Okay, so let's finish up 6.3. I think there's only one more little thing here. So the number in pica in a region is decreasing by 8% each year, and pica is some type of animal. I can't remember exactly what it is. Some type of a like a little ground squirrel. It's decreasing by 8% each year. Okay, so in other words, my r is 8%. Written as a decimal would be 0.08. How does the decrease for years 1 to 5 compare to the years 6 to 10? So we need to go on ahead and we need to write an exponential decay function, okay, for each of these. So I know that my f of x equals whatever my a value is, right? I don't know what that is. A times 1 minus 0.08 to the x power. Okay. So 1 minus 0.08 is going to be 0.92. I just want to double check. Yeah, 0.92. Okay, to the x. And it says, hey, so now let's go on ahead, and so that's all we can do, right? Is we can say that it's a times 0.92 to the x power. And so now it says, let's write an average rate or slope for each time interval because we need to compare 1 to 5 and 6 to 10. Okay, so now we need to do 0.92 to the 5th power and 0.92 to the 1st power. And then we can find those slopes. So 0.92 to the 5th power. Again, we would have to multiply by a at some point to find out what the actual population is, but right now we're just comparing the population. Okay, so we don't care what it actually is, we're just comparing how it's changing. Okay, so this is going to be 0.66. So 0.66, and 0.92 to the 1st power is 0.92. Okay, so now we have 2 points here. We have the 0.5, 0.66, and we have the 0.1, 0.92. Okay, so those are my 2 coordinates. Okay, I can find the slope of these 2 coordinates. Okay, and so it's my y2 minus my y1 over my x2 minus my x1. Okay, so 0.92 minus 0.66 is 0.26 over -4. And now let's divide 0.26 divided by 4, okay, and we get 0.065. Okay, so negative 0.065, which means there is a decrease of 6.5% each year from the years 1 to 5. Now let's go ahead and let's do the same thing for years 6 to 10. So we're going to do 0.92 to the 10th power and 0.92. I guess I should leave a little bit of room there to write the answer. Okay, 0.92 to the 6th power. So 0.92 to the 10th power is 0.43. And 0.92 to the 6th power is 0.61. Okay, so now I'm going to find my slope. So I have 2 points again. Okay, let's see, I'll write this in purple. So I have the point 10.43, and I have the point 6.61. Okay, so I'm going to have to move down here a little bit. So I'm going to do my y2 minus y1 over x2 minus x1. So 0.61 minus 0.43 equals 0.18. So that's 0.18 divided by -4. Okay, so if I divide that, I'm just dividing it by +4, so 0.045 negative. So that means that there is a decrease of 4.5% each year from 6 to 10. So in other words, so it says compare. Okay, so we want to know, how does the decrease for these years compare? Well, years 1 to 5 are bigger decreases. Right? That population's shrinking a lot more. Maybe it's because, there's not enough food to feed them all, and so they're dying off faster. Okay, right? But this is important information as well to biologists and other people who are looking to understand what's happening to, a population and why. Why is it dying off? Okay, we do this all the time in Alaska for sheep and moose and animals, and that's why the Department of Fish and Game regulates how many animals we can hunt if you're a hunter, how many animals you can fish if you're a fisherman, because they do exponential growth and decay and figure out how much is needed. All right, well, you guys have a great day, and I will see you all next time.